Yeah, welcome everybody. Okay, please, if you are online, let me know about the quality of the audio. Yeah, so today we are learning, we'll start with uh, Kaleidoscope, LLVM Kaleidoscope. So, to get started, I think, let me, yeah, so to get started, I think, let me check Twitch and see if there's anybody there. So, coming. Okay. Oh, oh, oh. Yeah, please let me know about the quality of the audio. Please let me know. Let me check the. Okay, let me check the chat here. So, if you are on, please let me know about the quality of the audio so that I will know if I need to adjust my mic or something like that. The chat. Okay. Yeah. So let's go. So what we need to do first is to set up our development environment. So I'm trying to learn. There's this build. Uh, there's this build environment called Mason. I mean build system. Yeah, let me put it like that. Build system. Yeah, called Mason. So I want to try it out. So I'm coming. Let's see. No. Okay. This. Oh, I don't know why I am getting this thing wrong. Uh, uh, I want to go to. I'm always having a problem with this YouTube studio waiting. Uh, okay. I think it's yeah, yeah, yeah. The control. Yeah, yeah, yeah. Nah, not made for kids. Let's continue. Yeah, I think we are here now. So I want to set up. Let's set up Mason. Um, let me see. So search Mason. Okay, Mason is present here. So so Meson build system. So we use that in managing our LLVM configuration. Do I have LLVM installed on my system? Please let me know on chat uh, if the quality of the audio is not good, please. So uh, okay, yeah, so this is Meson build system. Yeah. Okay. So let's see the let's name it Kaleidoscope. My son in it. So Z. I don't know why is that when doing this doing like this. So this is Z.C. Second producer is C file. And what you are using is C++. Let's see. Mason. Okay, let me do something like this. So my son and name. Okay, yeah. So Mason will create a build system. I mean, so this is the Mason. Let's add Mason extension. Let me check if there is. Okay, yeah. There's one for Z editor. Please, if you're on the Twitch or the YouTube, please let me know about the audio so that I will adjust the mic or I adjust my voice. Okay, we don't have the pro. Yeah, so let's see. It's not referable. Can I edit the code generated on it is reviewed by the BO subdirectory and executing image or compile command if your version is too old. You can compile the project. Okay, let's see. Mason compile. Wait, do I have to like? Okay. Do I have to? Yeah. So at the beginning of the tutorial, um we are going to write Alexa and something. So let's okay. Uh, Okay. This is how to compile it. So we have to specify the build directory. It's just like the way CMake also work. Yeah. Let's see. Yeah, we can add different executable, different sources. So I'll come here and then I'll add so that's CC. So this is C++ file. Meson build. AU. Okay. So let's do the running Meson. Today is just for setup. So we were going through the Meson. I just keep saying Meson. Uh, okay. We're going through Meson documentation. I don't know the command line. No. So the Meson is like a programming language on itself. Yeah. Okay. Yeah, so let's go. We set up our Meson already. Okay, this place. Please, if you can't hear my voice, let me know. We don't even have any watch any viewers there, so no need. So in this particular tutorial, we are building a programming language. Let me just copy and paste this. So. Uh, so that'll be the I've used this as the test program for the Fibonacci. So now we are building something like this, and then so from the beginning of you Kaleidoscope is a language that allows. So we want to define function, conditional math over the course of the tutorial. This time to support fed and constructs for loop, user defined operators, just in time compilations with a simple command line interface bug. I mean debug information. So we want to keep things simple. So Fibonacci, that's the classical one. Yeah, the Lexa. Yeah, so the Lexa is okay. I think I will do something like this, and then yeah. So definition. So the minus 3. I'm trying to write everything down in a way whereby I will be able to like have one-to-one correspondence with it. So mm, identifier is minus 4. Minus 3. So now, oh, minus 5. So this is our Tokun generic, I mean definition. So it should Tokun evolution, it should be an unknown character such as return the current token is an identifier, the identifier string. So yeah, yeah. So we have some static variables here. Static cd. So identifier string. So we are only supporting I mean, just a double number. So include. So let's include string. No, don't worry about that. So guess token. Let's do something fancy. Yeah. That's not fancy. Oh, it's not even fancy. Okay. Yeah. Do you have anybody else on the chat? Yeah. Gets token. Static class character while space. So I think I've already explained some of this from some of the last streams about writing Alexa. So why space like get character, and then so if it's a white space, so we just like skip everything. So now if it is an alpha, so y is alpha alpha plus character, that is the character that we are on. So identifier string is equals to, so that will be equals to the last character, and then oh no, this is an if statement. So if like the current character now is like a string, I mean it's an alphabet, so then we do this. So we want to get like the identifier string, so the identifier string will be like the current character. So hmm, what we will do now is that um while is alpha numeric, I think my glasses is cool. I'll get my glasses next week. I can't really see. So identifier string want to add, so the current character to identifier string. So while we are still like getting our character, so we'll add the current this thing, and then we now check something that, so if the identifier string is equals to def, so we'll return the def token. So at the pin, we are using something like, I think we are using like classes now. This will have been like a scope num, like scope num in scope num in C++, like to be able to scope the num. Like now that I'm just like accessing the file of the, I mean enum rather, of the enum from anywhere like this, so it will be scoped to that particular enum. So that, I think that's like enum class, something like that. I don't know, yeah, if I'm right. So if is equals to extend, so with the token extend, so else we return the identifier, like the token that this is just a normal identifier. So because if we look at our language constructs that we want to have, so the keyword that we have def, though we have a, so we are going one by one now. So we firstly want to support def and then extern first, so that's what's like. So then we also have identifier. So identifier are just like name of a function, it can be name of a variable, things like that. Yeah. So uh so that's okay. Let's pass digits now. So we've done for, I think, I don't know. Let me use what was in um how to generate better for me. Yeah, at least for the formatting. Okay. Ah, yeah. Sure. Is this the right thing to use? No, let me use. I think is this Mozilla? Oh, Mozilla. Oops. I think I love this. I like it. I like it like this. I like it like this. I like it like this. No, I like it like this. Yeah. Apparently, we are the only one here. So okay. Uh-huh. So for digits now, I think you need to pray now. I need to go and pray. So let me do something. Tomato. There's no. There's this timer. Okay, let me put a timer here. Let me go to Firefox. Timer. So the next 10 minutes, I'm coming back in the next 10 minutes. it now. Yeah. So I think now let's pass to digits. So if it's a digit, uh, so that is alpha. So if it's digit, the last character, if the last character is digit, or the last character is equals to dot, that is for the decimal point. So the number string, so that is the number that we do. So now we say we set up a do while number string plus the last string. So then we check for if our number is a digit, last character is a digit, or it's equals to decimal point. So num file, and so that will be okay. String to digit of so we convert it to string and then 0, and then return oh so that is to pass the number. So that is if the last character is that is the current character we are on is like the, I mean, it's a uh, digit. So if it's a digit number, so then just get a string view. I mean a string view. I mean, yeah, a template string. So yeah, and then okay, and then my runtime this plus yeah. So then we return the token number. So now the comments. So our comments, the comments we have. So it's an hash. So then what we will do for comments is if we see any comments, we are going to like we are going to do this thing. What do I want to say? We are going to skip everything until the end of the line. So if last character equals hash, so want to do last character is equals to nah, get character, that is keep going. uh, so we keep going like this until if we have end of string, and then while last character is not equals to, I mean end of file rather. So if it's end of file, so we just end it. So it's not equals to this, and then and last character is not equals to the return carriage. So if you're on Windows, now if the last, okay, if the last character is equals to the end of I mean if it's not equals to UF, so where am I writing this? So we continue getting the token. So now, so if we are at the end of the file, so what do we do? So we return token UF, and then so otherwise if any of our this thing is not an alphanumeric, it's not this thing, we don't have any of this condition being satisfied, so then uh, this character will be last character, and then so the last character will be, so then we continue to the next character, so we continue to the next character, and then we'll return the current character that we have. So the current character that I will go before we go to the next one, so we have this. So this is our basically our Alexa. Yeah, let me just put it like that. So for now, so what we are going to build next is the uh parser. So I mean the AST. So let's build the AST. or EST now. So basically what AST is just like a tree with node. Let me explain. I think TL. So the way AST work is that let's say um, we write a simple code like our function, for example. I mean, let's say let's go to the let me see the grammar. Okay, Fibonacci sequence. Okay, let's say for example, let me just use this as an example. Let's say that we have the let x uh, equals 23, for example. So if x equals 23, and then we want to build like an AST for this. So the way the AST work is that um, okay. Oh, I hate this thing. Oh, okay. So let's say this is a variable. So this is like an expression, or this is an expression. So this is like a variable expression. So in this variable expression, we have two different values. So the different value we have our x. So we can say that this is like var. So and then we have the uh, left hand side and then the right hand side. So the left hand side and the right hand side. So let me just connect this here. Yeah, so left hand side, the right hand side. So the left hand side here now is our x. That is the identifier. So you know what we've gotten from this lecture, and what we're going to be using in this thing. I mean in the AST. So let's say the variable tree. So is that if you have two values, so the left hand side, the right hand side. So this our x will be okay, let me which is x, and then the right hand side here is 23. So this is basically how a trio, I mean an EST look like. So uh now this right hand side, it can be any value. So and then we have like a strict rule on the left hand side to be like, oh, it must be an alphanumeric. It must not start with something. It must not be a keyword, or I mean a reserved keyword for our language. So for example, now someone cannot say that let def equals to 23. So for example, if you are in Python, you cannot say that uh, um, let if equals to 23, or let's say if is equals to 23. No, you can't put something like that. So this is because there are rules in the Python interpreter that says that, oh, this putting if that, I mean yani if is like a reserved keyword for the language, so you can't like assign it to another variable. So we see as we proceed in our journey with this LLVM tutorial. So yeah, so our AST now. So let's just build an abstract class, an abstract an abstract class. Oh, this is a destructor. Um, default. Now, number expression also it will have its own hair. Like now, this is an like number ahead. For example, this is a number. So number expression we have like its own value. Like this is a number expression. This is my value. So let's say we have like, can I say is it a node or for this? I don't know. So uh, so let's say num expression. So it will have its own value. Let's say 23. So it's be like, oh, now we are putting number expression in this. So this right hand side will be like a number expression, something like that. So it will be like, oh, this is the number expression. So oh yeah. Uh, so so we are inheriting from our expression AST, and then double, that will be the value. I'm trying to follow this holistically. So the number expression AST, so the constructor is so oh yeah. So that is the number expression. Now the code shows definition of the base expression, which is the number numerical literals. The important thing to know about this is that the number expression class captures the numeric value and the literal as an instance variable. So the numerical value, and then so to face later phase, to know what this third numeric value is. So right now we only create the AST, so there is no useful accessor methods. So now the variable AST, so this is just like for referencing a variable. So in a variable we always have like identifier. So referencing the name like a. So now uh, oops, 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 oops. kind of what's wrong with this? Okay, what's the problem? Oh, so binary expression. So a binary expression we have like like what I defined over here. So equals to it's like a binary expression. Or let's say I want to do like 2 plus 2. I mean 2 plus 3. It's like a binary expression. We have a left hand side and the right hand side. So things like that. So class. So the operator, that will be the operator, and then we'll store it in a unique pointer of expression left hand side and the right hand side. Uh, so the operator normally. So the right hand side. And then the move semantic. So now for the function call. Oh, oh yeah. Okay. I don't know if there's anybody messaging some message now. Uh, says switch. Okay. Yeah. So what we are. I mean, what I'm doing basically right now is I'm trying to define. Oops. I'm trying to define AST. So what you have the expression, the number AST, the variable AST, the binary expression AST. So let me try to explain this better in some way. So basically, uh, so an AST, which is which something as abstract syntax tree. So it's just like, let's say we are using a passage generator now, we'll have to define our grammar and then our syntax for our language. So okay, let's say that I have a program. Let's say I have int mean a is equals to 23, and then I say return a. So let's say that I have a program like this, and then I think, let me see if there's anybody. Uh, okay, now let's say I want to represent this as a syntax tree now. So normally this is a function. So okay, I'm looking for, let's see. So let's see. This is a function, and then it has a body. So the body now. So the body, it has a variable expression. So the variable expression, it has a binary operation. I mean, not an operation for per se. So I mean, then it has a return expression, something like this. So no, so now the way this function is, so uh, so the function name main, and then the variable expression. So let's say var, it has a name a, and then the name a. In the variable expression, we have a number, so it's been assigned to a number. Let's say 23. Is it 23? Yeah, 23. And then we have a return. Let's say return, and then we are returning variable a now. So this map to this. Okay. Hi, why is this thing? Okay, let me look it. Oh, this map to this, and then this map to this. So just like it looks like I'm tired. So, so something like that. Uh, I don't think that's the better explanation to give, but just a little bit tired, kind of. Yeah. So the call expression. So now the function is also it needs to have some argument. Unique pointer. So args public constant. Um, the reference to the callee. So a unique pointer. So I know because this is a vector. So and then uh, so the move. Yeah, yeah. I think I will stop on this. I will have to stop on this AST. So tomorrow we'll continue. I'll try to explain everything from the beginning because right now I am tired. I don't know. Since morning I've not uh, rest. Yeah, so we'll stop the stream there today. Thank you for everybody that came and log out again. Yeah, thank you very much. Yeah.